Okay, I'm going to do the homework assignment for section 3.1b. So this is homework. Section 3.1b is found on page 131. It's numbers 9, which is a proof, 23 through 25, which are finding values of variables, and number 28, which is also a proof. So I'm going to do this assignment so you can check your work. Okay, number 9, because it is a proof, my requirement is you have to draw the picture and write what you're going to prove next to it. So I'm going to first start by drawing the picture. Line A, B, C, and D. This is angle 1, 2, 3, 4 is on the outside. These lines are parallel, and these lines are also parallel. Okay, what am I trying to prove? Angle 1 is congruent to angle 3. My two columns. Okay, this right here is called the proof setup. You have the picture, what you're trying to prove, in your two columns, and your very first statement should be what you're given. They broke it up into two givens, so I'm going to follow the book. They tell you A is parallel to B, and this is given. Step 2, they tell you angle 3 and angle 2 are supplementary. And the question is, why? This is what you have to fill in for your homework. So, because I know that this A and this B are supplementary, and I have this connecting transversal, there's something special about these angles. They're called same side interior, and they're supplementary because of theorem. So this is because of the same side interior angle theorem. That's the reason why those angles are supplementary. Okay, step number 3, they tell you that C is parallel to D. This is given to you in the given information. So now we're going to use that given information in step 4. In step 4, they tell you angle 1 and angle 2 are supplementary. Well, let's take a look. C is parallel to D. I'm going to use a different color. C is parallel to D. Here's your connector. You got a letter U again. These again are same side interiors. So for the same reason as number 2, same side interior angle theorem. Number 5. They say angle 1 is now congruent to angle 3. It's like, how in the world did that happen? Well, you can't forget about the theorems you learned in chapter 2. And what you notice is this angle 2 and this angle 2 are the same. 1 is supplementary to 2, 3 is supplementary to 2, and you had a theorem that said if two angles are supplements of the same angle, then the two angles are congruent. And the name of that theorem is called the congruent supplements theorem. So this is called the congruent supplements theorem. And we're done with the proof, so we can end it. Okay, that takes care of problem number 9. Alright, the next ones you had to do is 23, 24, and 25. So, number 23. First thing I have to do is draw the picture that they give to me. You guys are drawing the pictures, it helps analyze what you're given. I know a box means I have a 90-degree angle. I have arrows, that means I have parallel lines. So I have parallel lines at 90-degree angle. This angle is 3p minus 6, and they say find the values of the variables. Okay. The nice thing is if I highlight the angle that's given and highlight the angle that's given and make my connecting line, I have just formed the letter F. That means that these are corresponding angles, and if the lines are parallel, which they are, then corresponding angles are congruent. So I set this 90-degree angle equal to 3p minus 6, and I can solve. I'm going to add 6 to both sides. 96 equals 3p, and divide by 3. P is equal to 3 goes into 9 3 times, 3 goes into 6 twice. P is equal to 32, and I'm done with the problem. The directions did not say find the missing angle, so you are done as soon as you find the variable. Okay, problem number 24. Again, I'm going to draw the picture, a little more complicated picture. I have the shape of a parallelogram with diagonals cutting through it. I know it's a parallelogram because these arrows tell me those two sides are parallel and these two sides are parallel. This is 42 degrees. This is W. This is Y. This is 76. This is V. This is 25. This one is X. And this one is Y. So I have to find 4 variables. I have to find out what V is equal to, W is equal to, X is equal to, and Y is equal to. I have to find those 4 variables. Okay, where do you start? Alright, let's start with the V. Here's my V, and I see letter Z's everywhere, so I'm going to use this transversal and find my letter Z. And anytime you got that letter Z, you know you're dealing with alternate interior angles, and according to the theorem they have to be equal. So V has to be 42 degrees. Okay, let's go to W. I'm going to do the same thing. I'm going to follow my letter Z's. Here's my W. This angle has to be congruent to this angle, so W has to be 25 degrees. I'm going to go to my X. I'm going to do the same thing. I'm going to follow my letter Z. Here's my X. These angles have to be congruent, so X is 76. And we're doing great so far until we hit the letter Y. Because here's my letter Y, follow my letter Z, and it equals the letter Y. This is not going to help me, so I have to take a different route. Okay, I'm going to fill in the values what I know so far. I know that X is equal to 76, so I'm going to fill that in. Y, I don't know. I also know that V is 42. Now the reason why I did that is because I want you to take a look at this whole thing right here. What I have here is the letter U, which means these angles are same side interior angles, and they have to add up to equal 180. And because they have to add up to equal to 180, I'm going to add all 4 angles to equal 180. So this 76 plus this Y plus this 25 plus this 42 all have to add up to equal 180 degrees. Okay, I'm going to combine my like terms. I'm going to add these together. I'm going to actually use my calculator because it's easier. 76 plus 25 plus 42 is 143. Plus Y has to equal 180. So subtracting 143 from 180, I get 37 degrees. So my Y is 37. And I'm done with my problem. Okay, last one, number 25. again, I'm going to draw the picture. And as I draw the picture, I'm going to analyze it. I've got these two lines which are parallel. I've got this Z shape doing this. Transversal coming out of nowhere. This is my parallel line. This is my parallel line. This is X. This is Y. And this is 3Y. Okay. Let's see what we can do with this. I don't have any numbers to work with. No numbers at all. Alright, first thing I'm going to do is I'm going to use this transversal. I'm going to mark it in red because this is the transversal that touches all of my angles that are given to me. Alright, I'm going to mark this 3y. Mark this x. And I form this letter F. So these are corresponding angles, so that I know that x is equal to 3y. That's what I know. Okay, don't forget about this relationship. Anytime you got a straight line, you can add the angles together to equal 180 degrees. So the other thing I know is that x plus y equals 180 degrees. You cannot solve this blue equation and you cannot solve this green equation the way they are. But what I can do is solve by substitution. Because I know what x is, I can replace it right here. X is 3y, so I'm going to replace this x with 3y. I have plus y equals 180. Combine my like terms. 4y equals 180. Divide by 4. Y is equal to 4 goes into 18 4 times with 2 left over. 4 goes into 25 times. Y is 45. I got to substitute back to find out what my x is. X is equal to 3 times 45. X is equal to 135. And I have my two answers. Okay, the last one is a proof, and it's for problem number 28. Okay, so requirements are you have to first draw the picture. So I'm going to draw this picture. This is A, this is B, angle 1, angle 2, angle 3, angle 4, and I have these arrows, which means I have parallel lines. What am I trying to prove? I'm trying to prove angle 2 is congruent to angle 3. I'm going to make my two columns. Statement number 1 is always going to be what you're given. So I'm given A is parallel to B and angle 1 is congruent to angle 4. This is given to me. Okay, now what I'm going to do is I have to somehow get my 2 and 3 into the proof. So let's use the fact that these lines are parallel, and I want to introduce angle 2. So I'm going to start with this. I know angle 1 and angle 2 are same side interior angles, therefore they have to be supplementary. So I'm going to write that down, that angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary. And the reason for this is the same side interior angle theorem. Alright, I'm going to do the same thing. I have to introduce my angle 3. I've got 2 in the picture, so I'm going to do the same thing on the other side. I know angle 3 and angle 4 also must be supplementary. So I'm going to say angle 3 and angle 4 are supplementary for the same reason. Same side interior angle theorem. Alright, I've introduced my angle 2 and my angle 3 into the theorem. Here's my angle 2, here's my angle 3. I have to do something with those to prove them equal. Somehow there's a relationship between this 1 and 4. It's found here. And you guys had this thing called the congruent supplements theorem. It says if two angles are supplementary to the same angle or congruent angles, which we know these angles are congruent, then those two angles are congruent. I'm ready to say what I'm trying to prove. I know these two angles must be congruent. Angle 2 is congruent to angle 3 because of the congruent supplements theorem. And you're done with your proof. Alright guys, you have a good day, and I hope this helps you with your own homework. Bye.